We are combining lessons 66 and 70. So we'll do 66 first, which is solving inequalities by adding or subtracting. And then lesson 70, a little bit of a wrinkle there, is solving inequalities by multiplication and division. All right. So let's have a look at a couple of important concepts from this section. First thing is that solving inequalities is the same as solving an equation, with one exception that we're going to look at in a moment over in lesson 70. But does anybody remember what the exception is? What do you do differently when you're solving an equation that you don't do when you're solving, an inequality that you don't do when you're solving an equation? Toddy? Yeah, one part where you have to flip the symbol. What is that part? If you multiply or divide by a negative value, then you have to flip the symbol. Okay? The other difference, and this is a subtle difference, but the answers of inequalities can be expressed as an inequality, and we've looked at all these already, and we're going to kind of remind ourselves of these three ways you can write the answer. It can be expressed as an inequality. We can graph the inequality. You had a homework assignment last night that told you to graph x is greater than or equal to negative 5. Or you can use interval notation to express the answer to an inequality. Okay? Now, equations, we pretty much just say x equals 2 and we move on. Graphing x equals 2 is very boring. Right? Just 2 on a number line. You don't really express the solutions to equations as graphs, but you can express the solutions to inequalities as graphs, and it's explicit. It shows you what you want to see. All right, so here's kind of some examples. Solve the inequality, graph the solution, and we're also going to remind ourselves about interval notation. But again, I'm not testing you on interval notation. I just want you to be exposed to it. X minus 10 is less than negative 6. What would we do to solve this? Add 10 to both sides, and we would get x is less than positive 4. What's the graph of that look like? Open circle at 4, right? Open circle at 4 and shade to the left. Why is the open circle there? It's not equal to. Closed circle means equal to. Now, the interval notation for this would be x is an element of the interval from negative infinity up to 4 with a parentheses. Why the parentheses? Again, the open circle. What if the circle was closed? What symbol would we use there? A bracket, right. So there's 3 different ways we can express the solution to this inequality. Now, you could expect on the ACT to see any of these 3 solutions. Right? I have seen interval notation on the ACT, more in problems than in solutions, but a problem giving you that. Yes?
Can you like graph something that's like this is equal to this, like that? Like if we ever get a problem where like instead of like greater than or less than it's equal to, you know what I mean?
Yeah, you could graph equals, but it's really boring, right? If this was x equals 4, what would that look like on a number line? 4. Yeah, just one dot at 4. It's just kind of boring. Yeah, but yeah, you can have a number line representation. Again, here, what would we do? You guys probably don't even have to write these down, right? You could add 3 to both sides, and what do we get? X is greater than 8, greater than or equal to 8. All right, now you might want to write that down and remind yourself what the interval notation would look like. You know, it's kind of good to know that. 8, close circle and shade to the right. What's the interval notation for that? X is an element of 8 to infinity. Okay? Again, the bracket shows the closed circle. It's an Algebra 2 skill. One that I don't think we emphasize enough here at North Point.
I just got the
Calculus, when you guys take calculus, and I say when because a lot of you are on that track and we'll get there. Some of you will kind of, attrition your way out of the track, but that's okay. You use this notation a lot in calculus. Interval notation is very common. It's all over calculus. All right. What about next example? Subtract 2, and we get x is, what do you think, Karis? Is that right? X is greater than 1?
Yes.
Okay. Then what would we do with that? How do you graph it? Open circle at shade to the right. Interval notation.
X is an element of parentheses 1 to infinity.
I don't know why I just wrote 0. It's 1, yeah. Okay? 1 to infinity. The bracket of the parentheses shows that the circle is open. Right? So we got that. All right? Number 4. An airline suitcase that weighs no more than 50 pounds when it is full. The airline allows a suitcase. Jared's empty suitcase weighs 5 pounds. How much weight can Jared pack in his suitcase? Write an inequality to solve the problem. Yes?
My mom just went to the airport and her bag was more than 50 pounds, so she had to unpack some stuff.
Yeah, they won't allow. They won't allow it. Now, listen. Write an there's two. This is a two-part problem. Write an inequality to solve the problem. So what would the inequality be? X plus 5, right? What you put in the suitcase plus the weight of the suitcase is not more than, less than or equal to 50. That's the inequality. And then so that means that the contents of the suitcase cannot be more than 45 pounds. Okay? So any value less than 45 pounds. It doesn't say you have to put 50 pounds in your suitcase. It says less. All right? Incidentally, when you're flying, you need to check with your airline what it's different airlines are different, right? So it can be kind of irritating. All right. Lesson 70. Lesson 70. Solve inequalities where multiplying or dividing by a negative is involved. Now, I want to kind of give you a warning. Y'all ready for this? In the next unit where we start doing multi-step inequalities involving dividing by negative, somebody, probably two somebodies in a class this size, will do their whole test and forget to flip the symbol when you divide by negative. That's bad. So it's extremely important that you remind yourself when you're solving an inequality that if you multiply or divide both sides by a negative value, you must reverse the symbol. You must. You must. Okay? Now, here's why. Let me prove it to you. This is a true statement, right? If we multiplied both sides by -2, what would we get? -4, -10, right? But this symbol has to be flipped to keep the inequality true.
Wait, how is that?
I didn't say it right.
That was right.
Mr. Henry, I said it right, and they all said no.
Because he was
But
saying,
it says
if you
less
do
than or
it,
equal to.
it was-
So you still have to flip the symbol.
Oh, y'all listen. Come on, y'all. Come on. Less than or equal to. It only has to meet one of the two conditions. Doesn't say less than and equal to. Now, that would be a problem.
Roasted.
Okay. So,
It wasn't against me. It's against.
all right. So 2 is less than or equal. Or. Okay. All right. I'm fixing to go somewhere. I need Nick or Sean to go with me.
Why?
I don't know. That's a bad choice, right? Okay. But that means just Nick or Sean, right? So less than or equal to means it has to be either less than the value or equal to the value. It can't be both. Ever, right? So 2 is less than or equal to 5. Which one is it? Less than. 5 is less than or equal to 5.
Would it be wrong to take away the little line underneath it?
On the second inequality or the first one?
Either one.
The second one would definitely be wrong because 5 is not less than 5. That's not true. That's not a true statement. Well, you said either one. Whoa. Well. All right. So that just kind of shows you guys that to keep the truth value of your inequality symbol, if you multiply or divide both sides by a negative, it kind of reverses, right? You have to reverse the symbol to keep the truth value of your inequality. So how would you solve this one? 1/2 x is less than or equal to 8. Or multiply by 2, right? That's the easier way. If you see fractions, eliminate the fractions by multiplying through by the common denominator. So multiply both sides by 2, we get x is less than or equal to 16. Okay? Now we could also do what with this solution? Sketch the graph or write it into an interval notation. But you know how to do at least one of those things quite well, so you're in good shape. Okay? Griffin, you got this? Don't say that. Don't say you got this.
Yeah, Griffin.
Don't tell me. All right. Negative x over 5 is less than 5. What would you do to solve this one? Multiply both sides by... It's going to need to be negative 5, isn't it? Because we got to get rid of the negative and the 5. Because I want to do it all at once. So I'm grown. All right? Now, when we're multiplying by a negative number, we have to reverse the symbol. That's the first thing you should write. As soon as you multiply by a negative, reverse your symbol. Okay? Now, on the left, the 5's cancel. Negative times negative is positive x is greater than negative 25. And that's the solution, right? How do you check an inequality?
You plug in the negative.
Okay. How do you check an inequality? Here's the graph, right?
You pick any one of the values.
Pick a value in here. What's a value in here?
2.
Positive 2 is negative 2/5 less than 5. Sure it is. We could pick another one, right? If we could pick 10 is negative 10 over 5 less than 5. Of course it is because it's negative, right? Any negative number is less than any positive number. So it would only be interesting if you picked maybe some negative numbers. If we pick negative 20, what about negative 20 over 5? Is that less than 5? Because that's 4/5, right? No, I'm sorry. 4. 4 is less than 5 is true. So to check an inequality, you want to pick values from the solution set and make sure that they make it true. Okay? All right? Next example. Now I want you to try this one on your own. Solve it, graph it, and write it in interval notation. Okay. What would you do? Cooper, walk me through it.
I divided both sides by 3.
And what did you get?
I got 6 is greater than R.
6 is greater than R. Okay. Everybody got to that point, right? 6. Okay. DJ, what'd you do from here?
I shaded it to the left.
You shaded it to the left. Is that right? Yeah. Because if we kind of looked at this, this is R is less than 6, right? And that's the mistake point on a problem like this, is graphing it. What would the interval notation be? R is some number between negative infinity and 6 with parentheses. Again, I'm not going to test you on interval notation. I'm just exposing you to it. Okay? All right? What do we do here? Divide both sides by -4. You got to flip the symbol. Okay? I'm going to flip the symbol right now because if you don't, if you're not conscious of that, it's just where you're going to miss these problems. And it's such a lousy way to miss a problem like that, right? So m is less than or equal to 7/4. -7/4. Okay? Can anybody go straight to the interval notation answer without graphing it? Good. Okay? All right?
Oh, me.
There's your homework.